Hello, everyone. I believe we can start. Welcome to the fourth lecture of the information visualization course titled Interaction and Evaluation, which kind of marks the agenda for today. We're going to be talking about adding interaction to our visualizations that have so far been static. And we're also going to discuss frameworks to evaluate whether our visualization is valuable. So the motivation for interaction is as follows. A static visualization only takes you so far. If you paid attention to the history section of the first lecture, this means roughly to the beginning of 1980s, when data started becoming a bit more complex and computers have started becoming powerful enough to tackle larger data. And it's the common understanding that to truly usefully understand complex data, you cannot do it without interaction or without a hands-on approach, because it helps if the user can play with the data themselves at their own pace. And interaction introduces exactly this dialogue between the user and the system, and it greatly enhances the cognitive process and also enables insight. If you look at the pipeline of both information visualization and visual analytics, so this is the visual analytics pipeline. The visualization pipeline is without the model. You can see that interaction is core to both, because we are so those are the blue arrows. So we're supposed to be able to manipulate our visualization in our quest for knowledge. And in visual analytics, our interactions in the visualization will drive the model. We're going to see this a bit more in detail in the visual analytics lecture. But interaction is really core to information visualization and all its disciplines, so that it can hardly be disentangled from the process. Before we start talking about the benefits of interaction in more detail, let's consider the cost. So, of course, the interactions should be snappy or non-laggy. Otherwise, the user will get annoyed fast. I mean, you yourself must have experienced a number of systems where your cursor has lagged, or when you click the button and nothing happened for 5 seconds. And we don't have to discuss at length that this is very annoying and can easily discourage the user from using our systems. So this is a system implementation challenge, and also in case of larger data sets, touches on the discipline of high performance computing. So that is a course of its own. So we are not going to be treating the implementational details very in depth in this course, but I still can give you a couple of pieces of advice. Good application design in this sense is that you pre-process your data as much as you can, or as much as it's needed, of course. So don't over-engineer your data, but don't be afraid of longer pre-processing if you do it just the one time, to really offload your computations in the interactive scenario. You also want to do the heavy lifting in your backend. So following the technology that you use in your practicals, you really want to do this in Python or in your Flask / Jinja server. And the front end should merely show the process data and take care of the interactions. So there shouldn't be very heavy data science computations going on in your browser, because browser is generally equipped to display things and not process them very well. And of course, last lecture we have talked about visualizations having a purpose. We really emphasized this point, and also interaction design should be purposeful. So the key question you should ask for each interaction that you design within your system is what task does the interaction help the user accomplish? So basically the tasks associated with interactions, which we're going to go over in a minute, are the queue in your Trifecta checkup for interactive visualizations. So never go, okay, the standard interactions are this, 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 and this, so we're gonna implement those. Always think about the purpose of your visualization, the knowledge your user wants to take away, or the question they want answered, and design interactions solely that they help achieving this purpose. So unpacking the science of interaction, there's this nice paper that is well called The Science of Interaction by William Pike and collective. It's optional reading for our course, and there's this what I believe useful diagram that nicely decomposes the problem. So on the left we have the user goals and tasks. On the right we have our interactive visualization and its capabilities, and the mutual feedback is the interface between the two. So our user wants to complete high-level and low-level tasks, and the interactive visualization should have means to facilitate this. So first, we're going to go over the high-level tasks, or over tasks in general, basically. So the difference between high-level tasks and low-level tasks is as follows. High-level tasks basically contribute directly to the useful understanding that we have stated in one of the first slides of the course as the goal of information visualization. This is why your user has opened up your visualization in the first place. So high-level tasks can be both the overall objective or objectives, but they can also constitute subtasks or steps towards those overall objectives. So it's the whole, and it's let's say semantically high level parts or pieces, like basically logical steps that you take if you decompose your bigger tasks into a smaller one. That's how you can decompose one high level tasks into multiple high level tasks. And low level tasks are basically those atomic subtasks that are necessary for you to really progress with your high level tasks. So going over the high-level tasks, the ones defined by Pike, we're going to follow their terminology. Is first explore. You want to find more information based on what you already have. You might want to analyze, which in the context of Pike means gather interesting statistics, characterize your data. And here it's important to discern analyze in this context, and the word analyze in general, which could also mean complete your high-level tasks in general. So this is the definition of analyze within Pike's framework. Further, we have browse. So that's basically show me something else. I want to look elsewhere for serendipitous findings or discoveries, basically. So those moments, oh, I didn't expect it here. Those eureka moments. That's what serendipity means. Then you have assimilate. So you want to get a grip on large and varied data sources. So think of something like some phenomenon like COVID, that you want to understand what's really going on, and you have an explosion of data. So to get to grips with what is relevant and what is not, that's exactly the assimilate task. Further, we have triage, which is that you define priorities based on data. So you make a priority decision based on your data. Then you have assess, which can be viewed as a bit of a generalization of triage, because there you make a general judgment about the data. Understand is kind of self-explanatory, and compare, where you want to find similarities or differences between two situations. So an instance of this could be a medical scientist comparing an incidence of cancer in different populations over time. So he or she might want to compare those differences between the two on the high level. And then if we go to the low level tasks, those are basically, so those are these atomic tasks, those minimal. So if you would construct an algorithm for your high level task, you want, these are your individual steps. So first is retrieve value. So you just, given a set of specific cases, you just find attributes of those cases. Then we have filter, very useful interaction that based on some concrete conditions conditions on attribute values. You filter the data and you find those data cases satisfying exactly these conditions. Then we have compute derived value. So some kind of aggregate numeric representation of data cases. Oh, and note also I use the term data cases here in this section, which is following Pike's work. But that means instances, basically, or data items, data instances. It's an equivalent term. Then we have find extremum, so find the minimum or maximum over its range within the data set. Sort, we don't have to go into detail there. Determine range, where you basically find the span of values. It's closely related to find the extremum. And the most detailed out of these is characterized distribution, which is that given the sample you have within your data, or the collection of values within your data set, you want to characterize the distribution, maybe draw a nice box plot. Further, we have find anomalies. So you're going to find pretty much the statistical outliers. Then we have cluster. So you can find clusters of similar attribute values if there are any present in your data. It's also useful to correlate your attributes to see if there are dependencies between them. Yeah, so this was the kind of the kind of list of tasks that you might want to complete. The conclusion is that you want to support the completion of high-level tasks, and the atomic steps are the low-level tasks. And of course, it also depends on your purpose, what kind of tasks you might want to support. So it's rarely the case that one system supports all of these tasks perfectly 100%. So it's so you have to select what you want to support. You want to have to design your purpose, and then find out the tasks that fall under your purpose, basically. Regarding the types of interaction, there we follow also like one of the cornerstones of visualization theory. That's a paper by C. Soon Yi and collective from 2007, and they give a very useful categorization into 7 different classes of interaction, which we're going to go over. What is interesting is that almost all interactions that are fathomable in an information visualization system can be mapped to these 7 or their combinations. And of course, we have to again emphasize that for the users, the functionality within the context of their task is key. So if you nicely model everything, but it's still not very useful to the user, then they might not appreciate that you're following Pike and Yi. So you always have to think about the context of the user's task. This is a framework to help you. So again, going back to the context, to the science of interaction. So now we have moved over here. So we're already in the visualization part of the diagram. So this is what the users need, and now we're moving on to what we can provide for them. So the 7 categories of interaction are select, which is that you have to mark something as interesting. Explore is show me something else. Reconfigure is show me a different arrangement of the data. Encode is show me a different representation of the data, so re-encode them in a different way. Then we have abstract elaborate, which is show me more or less detail, or you can this is known colloquially as the zoom interaction, so zoom in, zoom out. Then we have filter, show me something conditionally. We've been over this, and we also have connect. So you explicitly visually connect related elements in your multi-view or in your visualization. Going over so now we're going to go over those 7 in a bit more detail, always discussing the functionality, why they are needed, and what is called solution, which means like how you should go about making these interactions happen in your system. And we're also gonna show examples for each of those interactions. So the functionality of select is that it provides the users with the ability to mark data items of interest to keep track of it. So you have we have already seen in the last lecture there can be huge numbers of data items shown at any point on the screen. We might want to select the relevant ones to keep them in our visual memory. So this also ties back to the perception and cognition lecture that we had last week. Why select needed? It's exactly what I just said now. So you need this select to follow items of interest. And the solution, like how do you implement it? So you make those items of interest visually distinctive, so the users can easily track them. So here you will heavily utilize the Gestalt laws and perception primitives. So the pop-out effect. So you need your selected items to pop out. So use color contrast, which in turn means that you shouldn't overdo it with the colors on the non-selected data, and so on and so on. You can change the shape, you can highlight, you can maybe blur and focus, up to you. There are many ways to go about it, but rely on the theory learned in the second lecture here. Here we have an example of select. This is a network visualization system, basically designed by our colleagues from the Technical University of Eindhoven. Here you see I think that those are migration paths within the United States. So each edge is between the cities is one person moving cities. So here you can see that that they have allowed selection of two areas, and they show the edges between nodes within this selection. And here you have some detailed overview of the selection of the data. This paper has won best paper in at IEEE UvA, which is the best conference in InfoVis in I think 2015, maybe 14 or 15. I'm not sure now, but it has created quite a lot of buzz back then. It's a nice paper if you're contemplating doing something with networks or graphs. It's a nice paper to read, I believe. Further, we have Explore. So with Explore, we want to enable users to examine a different subset of data items than what they're seeing right now. And Explore is needed because you can always only view a limited number of data items at a time. Because as we discussed, we had problems with clutter. You don't show everything at the same time, or very rarely, and also with the cognitive and perceptual limitations of users are pretty much a thing. And basically, what you need to do here is you need to show a part of the data set. You have to let new items enter and remove others. So this has already been dubbed the visual entities budget in our in the aggregate section of yesterday's lecture. So that's again, it's not the same thing, but it's a very related concept here. So the Explore example. So there is this system called Visual Thesaurus. So what you do is you actually select something. You select something, then it will move to the center. So each of these are words. You select something, you move it to the center by the selection, and this will show relationships of the newly selected word to all the others. So you're kind of navigating the collection in this way. It's a nice example of Explore, and a classic one at that. And this is on a nice text data set, so that we also have some data variety in our examples. Another example of exploration is the Rotor browser by Org de Roy and Collective from 2010, I believe. So this is for exploration of videos. So you always have a center frame. You have a center frame that's a frame of one of your videos in your collection. And basically on the horizontal axis, I believe you always follow the flow of the video. So these are the previous frames, these are the subsequent frames. And if there are relevant threads, or if the AI model thinks there are relevant threads other than just the temporal axis of the video, it will show those logical threads here, like fanning out from the horizontal axis, for you to maybe follow that line of exploration. So to navigate you to a different part of the collection, which is related to what you see right now. Further, we have Reconfigure. The functionality there is that we provide users with different perspectives on the data by changing the spatial arrangements of representations. So the difference between Reconfigure and Encode is that Reconfigure just rearranges things that are on the screen already, whereas Encode means that you show a completely different visual representation. So you can also think of reconfiguring. The most common instantiation of Reconfigure is sorting your data on the screen, basically. And the need stated for the Reconfigure interaction is that the goal of the information visualization is to reveal hidden characteristics, and one perspective is often not sufficient. I mean, yeah, this is a bit of a high-level thing. My personal valuation of Reconfigure would be that it really helps you to establish ranges and to find extrema and find data instances that are my apologies, my voice. Excuse me. Yeah, so you can really easily find extrema with Reconfigure, and that is a very useful low-level task. So that will help you attain your insight quicker. The solution, of course, is that you change the way data items are arranged or change the alignment. So you're basically sorting the data on the screen most of the time. An example of Reconfigure: if we visualize data instances based on 4 attributes, these seem to be cars, cylinders, displacement, horsepower, and weight. So sorting everything by horsepower will lead to this arrangement, which also nicely allows us to discern the range of the data, so and the relative differences. So that's a nice example. And a multimedia example is from the Multimedia Pivot Tables by Marcel Worring and Collective. And there you can see, there you have a spreadsheet visualization for your multimedia data, and you can sort by columns there as well. So that's a classic example of Reconfigure. Another example of Reconfigure that we have also mentioned previously is related to stacked bar charts. So this is something different than sorting. We have said that stacked bar charts are a bit problematic when it comes to comparing the bars that are above the baseline. So what we can add a Reconfigure interaction such that if I hover over or click on the purple portion of the bar, then it will get dropped to the baseline, and now suddenly I can compare the purple portion of the bar quite easily, and the same could happen for the blue one.
Hey, Jan, 2 more minutes.
2 more minutes. Okay, so then we're going to go through Encode. Yeah, so let's do Encode, and then let's take a break. So the functionality there is that you're changing the type of representation, as I have telegraphed before. And the need is rather simple because different encodings show different characteristics. There are different strengths and weaknesses of different plots. And they explicitly mention that use is made of pre-attentive processing. So the solution is that you re-encode, that you show a different representation. And the slide that I have here for this is that you have like the same mock data set represented in different representations. So this is an example, or more of an abstract example of Encode. So I'm going to stop here. So do we have any questions, comments?
For now, the chat is still empty, so nobody asked yet.
Okay, yeah. So like always, feel free to ask your questions on Discord, so that we can have a discussion. It will help build you intuition. So yeah, let's take a break now. It's 1:24. I'm going to see you in 5 minutes at 1:29. Okay, so moving on with the lecture. The next functionality, or next interaction rather, is abstract elaborate. So the functionality is that we provide the users with the ability to adjust the level of abstraction in a data representation, or in more civil terms, so we allow them to zoom in and out. Why is this needed? Well, different abstraction levels are suited for different stages of the interaction, ranging from overview to detail. And the famous quip in the information visualization community is the Schneiderman mantra, which is overview, zoom, filter, details on demand, which is like the very, very brief summary of what many analytic tasks boil down towards. And we solve this by providing several levels of abstraction with a possible smooth connection between them. And we're, of course, heavily making use of aggregation here. So the last portion of the third lecture is very relevant for this purpose. So
Jan, we had a question.
Ah, okay. Sorry, I forgot to ask.
Maybe, Jan, do you want to ask it yourself? Let's wait a second.
Yeah, sure. Yeah, I had a question regarding the default view that we have when we have these interaction visualizations. Because basically my question is, do we just want to show if we, for example, have filter options, none of the filter options selected when you first go to the visualization? Or should we already select some which we think are useful? And the same for sorting. Should we not have anything sorted? Or should we already sort it in a way that we think is useful for the user?
Yes, that's a great question. So this is also famously known as the first screen problem. I mean, the most exact answer is depends, right? So if you want to, because obviously you're going to have to pre-select the data in a certain way, because we are not showing them on the screen all of it because of clutter and everything. So the default unbiased way to do this is to show a random sample. If you have so just randomly select data. So here you don't have to be really properly statistical, as long as you provide enough tools such as filtering and these interactions for the user to interact with the data set. My tip is that they sometimes help to fix the seed, so it starts randomly, but always in the same place, because sometimes if you reshuffle it with refreshes, users don't appreciate it. But I mean, you could, for example, I don't know, if you do price, if you have your data set is, for example, purchases of certain goods across a certain period of time, and you're showing this in a table, it might be useful to pre-sort them by the volume of that purchase, right, or the amount of money it went for. Because your purpose might be that the analyst might want to see how much like the most profitable customers for their company, right? So then that's an example where you pre-sort. But the general guideline would be that unless you have a specific purpose that you know that it will really assist the user to sort or to pre-filter, then don't do it. So if you don't have this purpose in mind, then the most unbiased thing is that just show something randomly, and let the users work with the data at their own pace, because obviously you want this self-evidence principle of your multi-view design, right? So you want the users to understand the visualization the moment they arrive, so they shouldn't have troubles adjusting the screen. I mean, this has been a bit of a long-winded response, but it's actually an important thing, the first screen problem that I didn't include. So thanks for this question. I hope I satisfied you with the answer.
Yeah, that makes sense.
Okay, perfect. Any other questions, comments?
L. Janssen asks, could you provide an example of the use of interaction in a virtual reality visualization?
Okay, so honest answer. I am not a VR expert, so I would be like pulling answers out of the air here. So here we are talking about interaction strictly in the kind of information visualization sense. right? So my belief is that if you're interacting within virtual reality or augmented reality, then this is a bit different, and there might be an entirely different classification for that, which is fine. But this is strictly in the InfoVis context, I'm afraid. I'm not an expert in VR, yeah. So sorry to disappoint that I cannot give a great example here, but yeah.
Yeah, I think that's it for the moment. So thank you.
Very good, very good. So we have talked about abstract, elaborate, and about this nice Schneiderman mantra: overview, zoom, filter, details on demand. And so to honor Ben Schneiderman, I have included this beautiful super 90s visualization as an example. So this is a very classic system called Film Finder by Alberg and Schneiderman, where you have this nice 8-bit palette which shows films by genre, which is your color-coded category, and you show the year of when it was released and some popularity index. So this is a scatter plot, colored scatter plot of films. You can, as you can see, you can filter by title, actor, actress, and director, and length, also ratings, and basically going from this overview to a zoom in is elaborate. So if you go into sufficient detail, then you also see the titles. And if you want to go from detail to overview, then you abstract and you go back to your main view. So that's a classic example of abstract and elaborate. If we think about tooltips, so that you click on something and then it will show a side view or overlay of that data point that you have selected, that is also an example of elaborate, actually. So you don't have to like zoom in, that like think about like using your mouse scroll wheel, but you can also elaborate by showing tooltips. Further, we have filter. So the functionality here is that we enable the user to change the set of items being represented based on some specific conditions. And again, too many data items will overwhelm the user. That's a principle that we have seen before. And the solution is that you just don't display items that do not satisfy the condition, or show them in a different way. So maybe some faded out towards the edge of the screen. And I mean, of course, you also need to support filtering by having some kind of efficient index or structure that you can quickly filter, because otherwise you're compromising the kind of user interface snappiness or responsiveness of your interface, which is desired. That's what you need to provide to your users. So an example of filter. This is an example of Uber data from Manhattan, which they have shown in the Kepler.gl visual analytics platform. And there's a blog post on this if you follow this link. So they're basically showing the traffic information recorded by the Uber drivers in this visualization. And here we have an example of a filter that you can kind of move the sliders, and you can see certain parts of the day. Further, we have connect. Connect, what it does, it highlights or associates data items. It shows their relationships, those that are already represented on the screen, and it will also show hidden items that are relevant to a specified or selected element. So it always goes hand in hand with select. And connect is a functionality which is very useful in multi-view visualizations. And why is it needed? Because if you show items simultaneously in different views, it's very difficult to see associated relations. And if you always show all relations, it can be overwhelming. So So the solution is that you show relations when the user selects an item, and you will identify the same item in a different view. An example is iClick by Van der Korput and Van Wijk. So what we have here is this is an image categorization visual analytics tool or multimedia analytics tool, where the users are able to create their categories of interest, so vacation, sports, airplane, or car. So here we see that the car category is highlighted. It's selected in green, and all those little green pieces that you see all over the rest of the interface are exactly those items that correspond to the car category. So you can see there some of their stats, date and time taken, histograms, their selections, like how many images we have of cars from Germany, United Kingdom, France, Belgium, or rather than how many, what proportion. So we can see that it's like that this is quite a lot of cars here. So this is mostly a car data set when it comes to Germany, and so forth. So this is a nice example of Connect, and a simpler example of Connect is what we have already seen yesterday. This is scatterplot matrix. We have selected these data instances in this scatterplot, and we are able to view the same points in the other scatterplots. So that is Connect. So those were the seven interactions. Sometimes you might also see the interaction called brushing and linking. This basically maps, so brushing maps to select and linking maps to connect. If you look closely at the diagram of Wijk, they see a difference. So they say that select and connect is high level and brushing and linking is low level, but that's such a nuance that we don't have to consider it separately for the purposes of this course, or I mean, for all purposes. I view them as pretty equivalent, and I'm not alone. So brushing and linking means select and connect. We have seen that connect is pretty much reliant on select. You can hardly connect things that are not selected. So we can collate the two sets of terms together. So what about going beyond the seven categories? So is it really true that all interactions fall into these 7 categories? Well, yes and no, basically. So most of the useful interactions from the analytic perspective do, especially if you consider compounds. So there are some interactions that combine elements of multiple basic interactions, basically. So first is semantic zooming. So what it does, it changes the representation of your data as you traverse the zoom levels. So on the bottom level, it will show the individual items, and as you advance up the tree in the hierarchical aggregation, then you might see some aggregate plots or things like that. And that's an example of compound interaction. So that's pretty much elaborate or abstract elaborate plus encode. You also have magic lens. So here you can see some manuscripts being scripted. They have been represented by text, and you can select the part, and it will translate it to a nice machine readable text interactively, or translate it. It's already, of course, already pre-translated, but it will show it in a readable form. So you can alternate between those two views. So there we see elements of select, we see elements of encode, and elements of abstract elaborate. Another famous technique is called scented widgets. Scented widgets are enhanced UI widgets with embedded visualizations that provide so-called information scent cues for navigating information spaces. So basically, we have the example here is that the widget are those radio buttons. So you can select option A or option B, and the visual scent is accompanying information that will help inform your choice. So you can see that there are like 44 comments under option A and 2 comments under option B. Here we can select our position maybe on a timeline. That's the widget, and you enhance this widget by the visual scent, where you can see the histogram of data corresponding to each of those individual choices. So scented widgets, widely used. We have seen them on a couple of examples before. They're at the very least they're filter plus encode, but it also depends on the visualization, on the visual scent. Basically, it can be more. So scented widgets example, we have already seen this. It's again this iClick where you can see this is exactly an example of scented widgets, because you can filter by latitude, for instance, and you can match the sliders so that you see most of the data, or you see the tails of the distribution. That's a crisp use of scented widgets. And going further beyond the 7, so of course there are general UI actions such as undo or redo, change configuration such as set theme to light or dark, or you're changing the display parameters, resolution, things like that. And we also have action history so that you can go back in what you have done. Those are all useful interactions, but we view these as auxiliary interactions. Those are not analytic interactions. So that's the distinction. You know, maybe we could also discuss that that for the VR purposes, some of these interactions with the world in VR or AR settings could also fall beyond this 7, especially if your application is not focused on data analytics but on something else. So I can easily imagine interactions beyond the 7. And that is to say that there are also analytic interactions that you couldn't categorize. So making this cut through a 3D distribution, there is a community disagreement on what this constitutes. So this cannot be categorized into the 7. So the 7 categories framework is pretty complete, but you know, you can make some interactions that could be useful and that fall outside. Maybe a scientific challenge to update the 7 interactions if you design a new useful one. And so now we have our building blocks. So now we have our seven interactions, which is a complete-ish framework then. And now let's look at a systematic approach to designing interactions in our visualizations. So how do we connect these atomic visualizations together? An interaction model defines how the interactions are related to one another, and also because we said that we needed to think about the user, about the functionality of the interactions in context of the user tasks. So we define how the different stages of analyzing data are actually connected by the interactions. So our interaction model is a very familiar thing to you as computer scientists, or to those of you that are computer scientists. It's a state machine. So the individual states are stages in the visualization process based on your different high-level tasks. So essentially, you can map this to the views in your visualization, because the views should serve a certain analytic purpose, right? But keep in mind that they are not necessarily equal terms. So the stages in visualization do not equal views, because in a pipeline style visualization where you follow a certain kind of directed graph process from the beginning to your knowledge, we might want to return to a view with interactions between the stages being different. So we switch off some interactions or make some more interactions available only in the further stage of the analysis. And this would result in one view being matched to 2+ states. So this is a useful thing to view the stages, but they're not 100% equal terms. And the actions are of course the interactions. So each state transition is pretty much one of the 7. I mean, unless you have some elaborate compound. If you have semantic zoom, you can say semantic zooming, or elaborate plus encode. I mean, if we're designing state diagrams, we should. Yes, do we have a question?
There's a question from Lucas. Do you consider an entire multi-view as one state or as a single state?
So yeah, that's a very good question. So I would say that by default, no. That basically a simple decomposition that you can do, and as we're going to see maybe a bit later, is that initially think of your views in your visualization as states, basically. if you have multi-view, because of course the user attention is only focused on one view at a time, right? So we're switching context if we're looking at views in our multi-view visualization. That said, if multiple views serve the same picture for the analytics purposes, then you can kind of collapse them into one node. So by default, start with one view per one state, and combine them if necessary, if this is good for your purpose, I'd say.
All right. Then Lianson asks, from an implementation point of view, when doing linking connect, are the computations performed on the fly, or is it just a matter of showing, hiding some parts?
Generally, connect, from my experience, is not that demanding, because you generally have some kind of index of the data or some pre-processed structure of your data behind your visualization, and there you have indices of the data. So basically, then if you say I have selected item 1818 and to 1850, then basically you can always quickly say, okay, you can call okay update view or update the other views. Then it will say, okay, now 1818 to 1850 should be green or contrasting now, and this is an interaction which is usually renderable very, very fast. So unless you're working with huge volumes, unless you're selecting large amounts of items every time, you should be fine. It works even with thousands, I would say. So I think yeah. So having pre-processed data in the first place is a good idea, but also for the general purpose. But should be fine. But this is very empirical. So you can try. So this is exactly part of prototyping, right? So you will try it without explicit optimizations, and if you see that it slows down your application, then you might want to have maybe some structure for frequently linked items, something like that. But this shouldn't be a problem generally.
All right, I think that's it for now for questions, and we have like 3 more minutes.
Okay, so I'm gonna talk about terminal states as well a bit, because we have if you have designed state diagrams before, terminal states are an integral part, and we haven't seen any terminal states here. For the interaction model, they are actually not that relevant because the users will never click and I am now satisfied button, or I want to end now. They will click the close button, and clicking the close button can be done at any time they see fit, whether they're satisfied or not. So that means that basically all states are by definition terminal, because you can the user can exit at any point regardless of their satisfaction. So that's something to keep in mind. And yeah, sure. I'm gonna wrap up. I'm gonna go over the example. So taking back the film finder, the nice 90s visualization, we have had the popular movies. So here we see one more view from the application that if you select a certain film, it will show you the title card. So it's an example of elaborate. So what you can, so working with Film Finder, you can think of this being, so starting with the assimilation phase, which is a phase where where you see all of those dots on the screen. You're kind of reading the axes, and you're trying to see what's in parts of the data set, getting to grips with the data. That's what the assimilate task is. You can filter, you can explore, which will refine your assimilation phase. Then you might want to go into a bit more detail. So not looking at the dots, but looking maybe at views where you can already see some of those films. So there you can keep filtering, you can keep exploring, of course. That's still available, but you're already in the exploration phase, which is basically that your side view stays the same-ish, and you change the zoom level here, and you have a different purpose. and then you change the zoom level again, and you watch details. So here, this is an example of us being in the detail phase. We're focusing on one particular film at a time, and and here we cannot filter within this because we see all the information here. We cannot really explore here. We just read the tooltip, right? And we can navigate between the phases by abstract elaborate. So we can go back from detail to exploration and back from exploration to assimilation. So I would stop here. So maybe are there any questions related to this example? I mean, you can also ask them at the beginning of the next stage of the lecture.
Yeah, perhaps that would be better because now there is nothing. Okay, let's do that.
Okay, so if there are questions, we're going to start with answering the questions, and then we continue with the lecture, and we're going to start at 2 sharp. See you in 5 minutes. Okay, let's continue. So, do we have any questions before we start?
Yes, Martin asks if we could spend a few minutes on the assignment because do you want to discuss it now or at the end?
So we can discuss it at the end because yeah. I'd like to finish the content, and then we can have general questions related to the course. Absolutely.
That makes sense. Then related to the lectures, Liansen asks, what are the most common types of optimization one can apply to get a more fluent interaction?
Optimization, you mean in the implementational sense, so like performance, so that your interface is not laggy?
Yes, implementation.
Yeah. Okay. So generally, basically, what you want to have is, and I mean, okay, this is going to be a very general answer. What you want to have is to have an index of the data / representation of the data, where with your visualization, so with the actual user interaction, you're not computing anything. You're just looking things up, basically. So lookup table is always the fastest thing. And most of the time you can actually succeed in this. So for instance, if you have something like filter, there it helps to have an efficient index structure to just quickly fetch any item that you need based on the user basically query. So filter is kind of related to search, right? So that's what you want. Explore, you can tie to the same index pretty much, because explore is basically show me something else than what I am seeing. So there, I mean, you can do something. Okay, so I am seeing a certain filter now. So I'm gonna see. So my filter is A. I'm gonna show not A, or a random sample of not A, because if with a filter you're reducing the collection to a small, very small portion. So not A is going to be large. So you're just going to randomly sample from not A, which is a reasonable way to explore, unless you have a better idea, which is then suited to your data purpose and the domain context of your visualization. Abstract, elaborate, again, those are pre-computed structures. So you basically aggregate, pre-aggregate your data before the users can actually access your visualization, and you're just traversing the hierarchy, again relying on the pre-computed stuff. If the user clicks the zoom in, zoom out button, pretty much. So those would be my guidelines or my suggestions. I hope that satisfies the question. And I mean, of course, for particular challenges that would arise from your kind of from your practical work, that's also what the weekly meetings are for, right? So for you to experience those challenges, and the TAs are supposed to be able to guide you with your particular problems, because I'm not really involved in the implementational part of your project. So my advice is a bit more general. But I mean, I hope that I have shared a couple of relevant points anyway.
Then I guess we can come back to assignment matters at the end.
Absolutely, yeah. Let's do. So that was the interaction model. So yes, and now to wrap up the interaction portion of the lecture, interactions massively improve the cognitive process of our users, and they unlock meaningful analysis of larger data sets, because just dropping static visualization of a large amount of data is never a good idea. We always need to design our interactions with a purpose. So we always have to ask what task does this interaction accomplish? And we have to ask this question for all of our interactions. And the 7 categories and drawing the state diagram will help you think about this in a systematic manner. So that's ends this section of the lecture. And now let's move on to the second topic, that is evaluation. I mean, now it's actually, again, if there are questions, now we're in a logical break in the lecture. So of course, ask away. Christina will interrupt me if there are any questions, of course. But moving on to evaluation. So the question we have to ask is, how do we know that our visualization is worth it? How do we know it's really good? Or given 2 designs on the same data, so we have some data and we visualize it in multiple manners. So which one is better, right? So yes, we might want to rely on the good practices, but in general, this is a valid question to ask. And quite frankly, it's $1 million question, and it's an open scientific challenge because there is no single standard framework where you input a visualization and you get an authoritative value of it, either in absolute, relative, or objective terms. So, and the reason for this is that information visualization, as we discussed, is not an exactly computable discipline. So some mapping from a visualization to a number that will rate your visualization, that is very, very hard. So, but I mean, this is a nice evasion of the question, but we still need to evaluate, right? So in the remainder of the lecture, we're going to discuss some possible approaches towards evaluation. So first, we can also rely, of course, on the Trifecta checkup, because as we have discussed yesterday, it's an evaluation framework too, and it enables relative comparisons. So the Trifecta visualization is better than either of the QDV. That is better than either of the QD, QV, and DV, and that is better than a visualization that is lacking all 3, so QDV type visualization. Also, it gives you an absolute-ish value of your visualization, so not in the numeric sense or in a very kind of fine-grained sense, but if you have a Trifecta visualization, then it's pretty much perfect. QDV is not that bad. You can maybe still improve it, but it's not horrible. QD, QV, DV might need a second hard look, and QDV is just a crappy visualization. So you need to do better if you think that your visualization might be QDV. An interesting criterion is proposed in the work of Jack van Wijk, and that is that you should search for and enumerate possible actions of users after they have used your visualization. So basically, your domain experts or people that are supposed to use your visualization for real to gain useful knowledge. And simply put, if such actions cannot be found or defined, then the value of your visualization is in doubt. And because you cannot just claim that the visualization gives insight. So this is tangentially related to what we had discussed yesterday, is that in the Trifecta checkup, that we're just showing an interesting data set. That's not a good cue. That's not a good question. It doesn't answer any questions. So this is the same thing. We are just giving insight. It's kind of a buzzword, right? So particular actions are valuable. I mean, it's very hard to find these actions, but it's a very tough criterion. But but there's a point to it, definitely. Another thing, another way you want to approach this, you might want to approach this, is to establish the desirable InfoVis attributes. So in the beginning of the course, we have talked about the classic by Edward Tufte, which specifies 2 categories of desirable attributes for visualizations. And that is visualization excellence and visualization should-haves. So like 2 tiers of categorizing your visualization. So it can be used as a checklist. And while this is not the standard, I would say that very few people in the InfoVis community would disagree with these points. So what are they? So visualization excellence means, I mean, your visualization for it to be excellent, it should consist of complex ideas communicated with clarity, precision, and efficiency. Your visualization is that which gives to the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. I mean, we're of course thinking about virtual ink in the modern context, but the point stands. Another attribute is that it's nearly always multivariate. I mean, let's admit this attribute is a bit dated because virtually all worthwhile visualizations these days are multivariate. So keep in mind that this book has been written in 1983, so that's a while back. And 4 is that it requires telling the truth about the data. And we're going to see what the truth is from the next slide, basically. Those are the visualization shoulds. So what your visualization should have, even if you're not aiming for it to be excellent. I mean, it should show the data convincingly. That's simple. The second one, I especially like this one. It should induce the viewer to think about the substance rather than about methodology, graphic design, the technology, or something else. So if your viewers are looking at your visualization, you really want them to think about the data or about the contents of your visualization, not why did they choose this kind of visualization? Oh, why do they have these colors? And what does this button do? You know, they should really start working with the data. I mean, of course, there is, especially if you have a multi-view design, there is some learning curve before you can really delve into the analysis. But I still believe that this point by Edward Taft stands, and it's an interesting one to think about. The third one is that we should avoid distorting what the data have to say. And this is exactly the first step towards the truth attribute in the excellence category. So the truth here means that you really characterize the data, you master the data pretty much. That's an excellent visualization. The first step is that we have to avoid distorting, which we have discussed namely in 2 forms, which was overclaiming and manipulation yesterday. We really want to avoid that. And the fourth aspect is that we should present many numbers in a small space and make large data sets coherent. So note that here, present many numbers does not mean cram a lot of data on the screen, but rather make many numbers accessible. So make users able to access data which is normally inaccessible, basically. If you want to go further into a bit more formal model of visualization, then there are many. I think the most useful one is from the already mentioned paper by Jack van Wijk, and that is the Van Wijk's model of visualization and the economic model. We're going to go over these two in greater detail. So these are your components of visualization. This is the data. This is your visualization, as is the settings for the visualization, including the hardware, including the context beyond just the window within which the visualization happens. The visualization is, of course, dependent on the data and the settings for the visualization. It will produce the representation, which is called the image, hence I. The image is perceived by the user, so that's the P, perception, and it hopefully leads to knowledge, namely to the delta of knowledge over time, or basically the change evolution over time here, derivative. And the knowledge, of course, influences perception, which is logical. So a more experienced user, more domain knowledgeable user will perceive things more efficiently. So this is a positive feedback loop, of course. And then basically I forgot what the E was. Yes, exploration. Sorry. The user, based on their knowledge, is going to explore the visualization, and the exploration is going to drive changing the settings of the visualization. So this is the settings as we discussed. So the objective settings that are done once for the session, but also the settings of the user. So which view am I going to view? and how much time I'm gonna spend. And of course, the settings evolve over time. So for a certain task, it could be well the case that a certain combination of views and visualization elements within your visualization are the most efficient components for you to perceive a better image, pretty much. Yeah. This slide was a bit of a cheat sheet for me. It's also is here. This what I just said now. It's for you to read when you're reviewing the slides. Basically, I have just talked about this. So obviously, in Van Wijk's model, we want to maximize the change in knowledge over time, right? Note that with bad visualizations or visualizations that are misleading, this term can also be negative. So by using the visualization, you might go to wrong conclusions, which might impair your domain knowledge. So that's an interesting notion that was made in the paper. So yeah, we want to maximize this, but it's still pretty abstract. So how do we determine the value? Well, it depends, right? So it depends on the perception, which itself depends on the domain knowledge and on the visualization. And the visualization depends on the data that we have, the settings that we have, and the time that we spend. So it's pretty much an entangled mess. I mean, and this is kind of a truthful state of affairs. So let's not sugarcoat it. But there's a way. So Van Wijk proposes a so-called economic model of visualization. And the idea is that you calculate the profit of your visualization. So basically the profit is denoted F, and these are your benefits, and C are your costs, which we're going to go over in a minute. So this is just to set the letters. So we have n users. Each of the user will use the visualization for m sessions. So we're using the visualization continuously, and each of the session will take k exploratory steps. So your benefit basically is the delta of knowledge. So the knowledge gain, which is like a shorthand for the other notation. So this is shorthand for this. And the W is the economic worth of that attained knowledge, and of course it's multiplied by the number of users and the number of sessions that your users have conducted. And of course, you subtract the costs from your gain here. And the costs associated with the visualization are at least the following ones. So the initial development costs. So because the visualization has to be developed and implemented, you have to buy hardware for it, and so forth. Then you have the initial costs per user. So in the paper, it's costs on the side of the user. So the user will have to spend time on selection, acquisition of the visualization. They will have to learn it, and they will have to customize it, maybe also install it. I would say that if we look at this from the designer perspective, which might be useful for us further in the course and beyond, I'd also put costs associating with acquiring the user here. So maybe your marketing costs, you really want to draw attention of the user towards your system. Then we have initial costs per session. So we have to convert the data. We have to initialize the visualization. Maybe we need to pay a person to sit there with the user and guide them through the session if it's a test session. And finally, we have the perception and exploration cost. So that's on the user side. So understanding the contents of the visualization, steering it, basically you're enumerating your cognitive load. The total cost is simply the sum of all these costs, and it's interesting to note how many times you pay each of them. So initial development costs you pay once, you develop the system. The cost per user you pay times the number of users, which is also hardly surprising. Then we have initial cost per session, so you have to you count that cost per user and per session. And then we have perception and exploration costs, so that's per user, per session, but also per the number of steps that are taken by the users during the analysis or during the visualization session. And if we put it all together, then we have a formula like this. That's pretty much just putting the two formulas together and doing some kind of modifications, algebraic modifications. And if we kind of unpack this from the so you don't have to like remember this, of course. It's useful to go through it if you're calculating the cost of your visualization, but it's not that you will have a question in the exam, write the formula for the economic model in full. That's not going to happen. This is just for you to, as a framework, to know and to be able to use. And if we unpack the terms, so obviously we want high W delta K and M. So of course we want that's hardly surprising. I mean, we want lots of users using the visualization a lot, and we want them to have high knowledge gain and high worth of that knowledge gain. That we want low costs is hardly surprising. But what might be a bit surprising here is that we really want to keep the number of exploratory steps per session, or the K, low as well, basically. So because that only is projected to the costs, not to the benefits. So, but this, if you recall how we stressed that interactions should truly help users in their tasks, they shouldn't be bloated, they shouldn't be there just for the sake of being there. This kind of makes sense, right? And if we quote the point made about interactions in the paper, Van Wijk says that interaction is generally considered as good. One could advocate the opposite. Interaction should be used carefully and sparingly. So again, the less is more principle that should resonate within every design choice that you're making when designing visualization. So yeah, great. So we have this model. But how do we actually assign the values, right? So it's all pretty much abstract at this point. So, and again, I know I'm getting annoying with this kind of answer, but it really depends on what you intend to do with the visualization. So is it a scientific prototype where you don't want to overwhelm the user, or is it a commercial project? Depends on your intent. What you expect to gain from implementing your visualization. So one way to think about this is that if it's an economic model, then you just take the economic perspective. So you just count the money. So W delta K is the money you make from a user using your system per session, which is interesting, and also valid notion business wise, because I mean, if you're creating a software company, then it's important to also think about this, because generally people are just setting the price of their software, right? Or maybe price of their software per month if it's a software as a service. But it's interesting that this per session notion also comes like directly at the core of the InfoVis science, and it's an interesting notion to think about. And your costs are your actual costs. So to develop, to market, maybe to acquire your users, you know, basically what your company pays to make everything happen. Another perspective, a more, let's say, scientific perspective, if you're looking at it from, you want to write a nice paper about visualization, and you don't really care about your visualization making money, you just strictly take the user-centric perspective. So basically, so WK is the knowledge benefit attained by the user using your system per session. So you talk to your domain people, how should you enumerate this? And costs are time spent by the user. So basically, the more time the user has to spend to attain the knowledge, that's your penalty. So you take a completely non-monetary perspective. But the main reason why I believe this framework is very, very valid is that even if you don't quantify the values exactly, and just use high, medium, low, the framework is still useful. So if you go here and you just say, okay, so yeah, I mean, I only have like moderate worth of the knowledge gain, and my costs are super high, then it tells you something, right? So even if you do this as not as an equation, but as an intellectual exercise, this might also shed some light on strong and weak points of your approach. And I have mentioned this paper a lot. It's optional reading for this course, but I really strongly recommend that you read this paper. I would even say that if you read just one optional reading for the entire course, this should be your choice, because it's not an evaluation paper, even though we have the mandatory part that comes into the lecture material that is required to be learned. Is evaluation, but this is not an evaluation paper. It's actually a deep and yet very readable, relatable, and I would say at times even lighthearted treatment of how to judge, evaluate visualization in general, philosophical points, things that InfoVis takes for granted, but might not be the case. And you have some reflections on InfoVis as a discipline and science as a whole. And if you don't believe me that it's a good paper, that is still worth reading, even though it's old, it has received the Test of Time award at IEEE Vis, which is the top InfoVis conference last year in 2020. So they awarded Test of Time for 10, 15, 20, and 25 years. So those are selected papers that, or one paper per category, that is still being read today, basically, even despite it being old. So this has won 15 years, so I can recommend this, and we're going to have Jack van Wijk as a guest lecturer later. So this is certainly my recommendation, and we're approaching the time, right, as well. Christina?
Yes, I'm still here. Yes, we also approached the time, so it would be like 2-3 more minutes indeed.
Yes. So let's have questions if there are any.
For the moment, there were no questions. Just I'm not sure. I can just try and ask if D3, the software, it doesn't scale up to large data sets, but.
Yeah, I mean, again, this is not like a course content thing, but this is my experience as designer. So D3 is very good for scientific prototyping, right? So if you're wanting to really visualize tens of thousands of data items using D3 as the kind of engine to do this, like if you're just loading it into the front end, then you might indeed have performance problems. D3 is a bit weird that it mixes the presentation part that I have talked before. So for your front end just presents things, and but it also kind of has possibilities for you to do the heavy lifting within D3, which is kind of a trap, right? So the thing is that. But D3 is still. I mean, I have written a similar response to one of the students in Discord a couple of days ago. D3 is a trade-off, right? So it's rather accessible. So we are a multidisciplinary course, and not everybody is an experienced front-end developer. So if you're an experienced front-end developer, then you might want to use something like React or Node.js for your production level visualizations. But D3 is still a widely used library. Even I've seen also some kind of practical uses in the past. And it's very accessible to people that don't have that much front-end experience. So this is a thing we're balancing. So I don't know. This is a bit of a general response, but yeah, that would be my take on it.
All right, thanks. There might still be another question.
Absolutely.
The student is still typing. Perhaps I can find him here. Do you want to ask your question verbally?
Yeah, I was going to ask about P5JS instead of D3 as well.
Mm-hmm, mm-hmm.
So that would be okay as well, I'm guessing.
I must admit I'm not. So did you say P5?
Yeah, P for Papa, 5 for number 5.
Okay. So I'll admit I'm not experienced with this library. So I mean, again, if you're an experienced front-end developer, I think the general line is that use whatever gets you past the goal line, and but note that we can only support those technologies that are specified by the course requirements, basically. So I for example, I mean, I'm generally not involved in debugging the assignments myself, but I have zero experience in P5, so it would be I cannot vouch for it. I cannot support it. I cannot ask students to know it if I don't know it myself, right? So, but generally, we're not against any technology that you're comfortable with. So it's not that if you have prowess within P5 that we're forbidding you to use P5 if you're able to complete things, and that you have to use D3 instead. I think that should be the line.
Okay, thanks.
Yeah. Other questions?
Just checking.
I've got a question.
Yes, sure.
So currently I'm kind of struggling with getting a transition working in D3. And it's like I've used one of the basic functionalities, like we're not going to use it probably at any other point in the course, but I've made a pie chart because why not?
Sure.
And but somehow I don't seem to be able to get earlier values or whatever out of it. And right now I'm just trying to butcher something together with it's like delays and whatever, so I somehow get a transition going, but this does not seem to be the goal. So what my question is are built-in methods from D3 recommended at all? Or should you just basically write everything in components? It's like squares and arcs and whatever, and just disregard the rest of the library, because this is taking way too much time.
Yes, so I understand the question. So, but I'm not sure I can answer authoritatively for the TAs here, I'm afraid. So yeah, so the thing is that I had very little to do with creating the assignments themselves, right? So this is basically maintained by the TAs. So this is more of a question for them, but it seems like a reasonable question to ask. So I can so let's get an answer from them, and I can get involved in the discussion. That's the if you want me to. But I mean, generally,
yeah, I guess I'll ask it in Discord then.
Yeah, so like if you feel that you didn't get your answer in a timely manner, or if there are some like issues with the communication between the TAs and you students, then yeah, we can discuss that. But this is a very particular question related to the assignments, and this is more for Georgi Inske and the team, I'm afraid. Yeah. Okay, so if there are no further questions, then we can meet again in 5 minutes, which is 2:36. I'll see you then. Okay, so let's wrap up the lecture and then spend some time on the practical parts of the course as discussed. Unless there are any questions right away, I can continue. Okay, so moving on from Van Wijk's evaluation model and the economic model, let's talk about interaction costs. And again, I know I'm sounding like a broken record, but they are notoriously tough to assign, especially in the absolute sense. So what is the cost of your interaction for a user? And the reason why it's tough to assign is because users are all different. Some of your users are going to blast through your visualization in tens of seconds. Some of them need 20 minutes to really let the visualization seep in. So that's why we cannot assign an absolute value for each of those interactions within your state diagram very easily. But what we can do is we can evaluate all of those actions relatively, right? So we can establish relations between interaction pathways towards completing a high-level task. So what we can do is we can count the interactions in our system from the 7 categories. So basically those A's in our state diagram. As an extra step, if we feel up to it, we can vary their costs. So select might have a cost of 1, and filter might have a cost of, let's say, 3. So of course, all of this is arbitrary, but it also reflects that setting a correct filter is more difficult than, well, 3 times as difficult in this sense than just selection. So unless you're really publishing a paper on this, you can use this. You can use this weighting as it works for you. But if you're in doubt, you can just count. So the weight of each of those actions is simply 1. And then what all you do is that for high-level tasks achieved or supposed to be achievable by your system, you just sum the expected costs of interactions required to complete them. So this should give you quite some nice insight into bloated interaction pathways and also imbalances. So do some tasks take way longer time than other similar tasks. Okay, so we have had a couple of interaction frameworks, sorry, evaluation frameworks, and there are multiple. So these are not the only ones in existence, but those that pretty much I have selected as useful. But use them to your benefit, of course. But we all know that the real evaluation is tests with real users. So, and that is, of course, that is again quite tough, because in the ideal world we would have thousands of users, so that we would have statistically significant results. They are willing to test any change we make whenever we need it, and without any effort required from us. That would be perfect, right? But I mean, it's hardly a surprise that the world is far from this ideal. So how do we go about evaluating with users? There are essentially three approaches, or three groups of approaches. The first one is benchmarks. So that is quantitative evaluation. So it's a repeated test drive on a carefully designed benchmark data set. Then we have Likert scales, so questionnaires. So that is a combination of quantitative and qualitative evaluation. Basically, the users experience the visualization and then grade it. And finally, we have insight-based evaluation, which is an example of qualitative evaluation. We have open-ended questions about the insight attained during the evaluation session. Starting with benchmarks. So benchmarks are all about a very, very precisely specified evaluation session scenario, which is including but not limited to the exact data set to be used, the very specific task to be completed, the task-dependent evaluation criteria. So those are the metrics that will allow you to exactly measure results. So that could be accuracy of the derived statistics, or things like precision recall or mean average precision. And we also have strictly set task-independent evaluation criteria. Again, hard set, very crisp parameters. So the maximum time allowed to finish the task and the number of interactions allowed to finish the task. So what the advantage of benchmarks is that they are predefined and consistent across test users. There are very specific instructions for the users. The completion time is capped. And it's also important that the individual tasks are very, very short for a large number of repetitions with the same user. So you really want to go for a high number of repeats. The answers that you get from the benchmarks are very definite. So you will get a number which you can then compare. Those are the task-dependent evaluation criteria. You will get a number, and you can compare your approaches among each other. With basically Boolean truth values, true or false. But the downside is that the answers are very simple. So they are very, very simple scopes, because we have had a short task on a predefined data set with specified instructions. So the users are not allowed to really explore the UI. So we have definite answer to limited scope questions with benchmarks. Likert scale questionnaires, there basically what we're doing is we define two versions of the visualization. So they're differing in what we want to evaluate. We define a set of questions with Likert scale answers. So Likert scale is what you see here, ranging from not at all interested to very interested. We define the task to be completed with instructions that are generally less detailed than benchmarks, and the tasks are more open and they can take longer. So we can broaden the scope a bit. So the user can decide basing on complex information they have attained during the session. Then we of course collect the answers from our users, and we score the two versions, which will give us some numeric representation of each of the versions. And of course, it's best if we can A/B test, which means that the set of users per version will be disjoint. That each user will work with exactly one version of our application. And so that is of course quantitative evaluation. And if we add open text questions such as any other comments at the end, then we have a hybrid of qualitative and quantitative. So that is a bit of a middle of the road approach. Finally, we have insight-based evaluation. So the word insight has been circling around these lecture slides for quite a while. So let's peg it down. So the dictionary definition is that it's the capacity to discern the true nature of the situation, the act or outcome of grasping the inward or hidden nature of things, or of perceiving in an intuitive manner. So you gain intuition mastery over your data, over your problem. In the InfoVis theory context, insight is best defined through its 5 attributes, which you can then, of course, look for and perhaps evaluate. So insight, so first is complex, that insight is complex and that involves all or large amounts of the data available. Deep means that you need iterative session, because it will build up over time and accumulate on and build up on itself, generating further questions and further insight, basically. Qualitative means that insight is not very exact. It can be uncertain and subjective. Unexpected means that you can find nuggets of great knowledge in unexpected places, these eureka moments, so unpredictable, serendipitous, and creative. And relevant means that you should always gain insight within your data domain or your domain knowledge, basically, that you connect the data that you see within a visualization to existing knowledge in your head, and it goes beyond dry data analysis to relevant domain impact, as Chris North has written. So what is insight-based evaluation, if we're going for insights then? So we design a very, very open-ended task with little instructions. So we just kind of drop the users right into our system. And for best results, it's of course good if the users have domain knowledge of the data set that we're actually showing, so that they can leverage the relevant component of insight gaining process. Before the session, we identify key insights that we believe the users should gain in the session. So, but of course, we keep them secret. We keep them for ourselves, and we can use multiple insight levels. I mean, we don't really have to go over all of these in detail, but going basically from general observations to really like crisp hypotheses, really like mastery of the data. So obviously insight can be shallow, or it can be deep. So that's what these five stages are about. What is important that you employ the so-called think aloud protocol. So the users speak their mind completely freely throughout the session. So at any time during the session, they can voice their insights, and they should be encouraged to. And it can be about any topic relevant to the visualization, the task progress, what they're doing, their user experience, everything that is related to what they see on the screen. It's very good if you timestamp the user insights for a reason we're going to see on a slide later. And here it's important that the session time is unrestricted. So because the time a domain expert needs to complete the analysis within your system is a valuable information as well. So did you actually really enhance their process that they're used to, or does your visualization take 1 hour 20 for a thing that the expert can do it within 40 minutes, right? But of course, it's unrestricted, but it's very polite to give the users an estimate. So this should take you tens of minutes. This should take you a couple of hours, so that you don't invite someone, it's just going to be a minute, and then they're kind of forced to sit there for 5 hours, right? And your design takeaway is basically the union of user comments. So which you can then sort by the number of users making a similar comment, right? Because they might be overlapping. So if you actually timestamp your insights, then you can view insights in a nice plot. So here we have an example from the multimedia pivot tables paper, is that we have 4 users with different background knowledge, and we have structural insights and conclusive insights. So blue dots are structural insights. Those were basically observations about the data, and orange dots meant conclusions or judgments reached about the data. We can map the session length, and you know, this plot can give us quite some nice information about our evaluation. So if we look at the design takeaways for evaluating with users, there are different strengths and weaknesses for all of the 3 approaches. So benchmarks are great for repeatability, comparability. You get an exact number, and low entry knowledge level of users, because if you know, insight-based needs knowledgeable users, and those can be difficult / expensive to procure. Insight-based evaluation is best for feedback depth, because you really get detailed answers and you get really open answers and insights that you might not have even expected before. The feedback is variable, so it can be about anything, and it's very there's very high level nature of the feedback. So you really get like usability guidelines for your future round of implementation, perhaps. And the questionnaires are middle of the road, right? So they're positioned between the two. So you know they're kind of a hybrid. And of course, for the most complete evaluation, it's very good if you combine techniques. So to conclude our lecture today, interaction is pretty much required in modern information visualization because it unlocks true data analysis and understanding potential. And evaluation is very difficult because it has an approximate nature, but useful techniques still exist and you should be evaluating your visualization. Here's the list of references with one highly recommended optional reading. So we can end it here. So first, before we move on to the course organization related questions, are there any questions related to the content of today's lecture?
Not sure, that's more related to the project.
Okay.
But yeah, I can ask. So is the evaluation supposed to be part of our project as well?
Yes. So the project, I believe, is to write a scientific paper, basically, and empirical evaluation, unless you have mathematical proof, is always required. I believe, I mean, we're going to have, and that might actually answer a lot of questions related to the course organization. We are going to have a coordination meeting with the TAs, me and the TAs, to kind of coordinate the requirements of the final project with what's being told in the lecture. I'm gonna ask there, and we should make this known in a concise manner. I don't expect that within the 6 weeks or so we have remaining for the course, you will actually be supposed to conduct a real user study, right? So at most, I believe it should be about that you actually design your evaluation meaningfully so that you apply the knowledge gained in this lecture to design meaningful evaluation for your system. But it's going to be it's probably going to be in the mock-up stage. So it's I think it's completely infeasible to fully conduct user study with results within the time framework of the course. It might be useful, but again, we're going to discuss this with the TA. So this is my musing now. This is not authoritative info. Okay. But it could be useful if you have a friend that might be interested in your project, that you kind of try to run the protocol with them. But again, I'm not saying at this moment that it's going to be mandatory to get X friends to do evaluation for you, right? But demonstrating the knowledge about evaluating your visualization will definitely come back in some form further in the course.
Thanks. I think. Yeah, someone asks, Liansen asks, are there also recent papers about interaction?
Recent papers about interaction, as in interaction theory? So,
I tried to find a student maybe here on... I cannot find him here on Zoom. So
yeah. So the general answer is that I'm not aware of any key papers about interaction theory from the recent years that it would kind of, let's say, add new interactions to the 7 or create a new interaction framework. There might have been some, but what we present here is the community standard. So basically the universal language of InfoVis science practitioners basically and researchers, that they would understand the 7 interactions by Yi. So I cannot rule out that there has been a paper, even a nice paper, that talked about interactions, but the community standard is what we have presented today, basically. That's the answer. But for example, an interesting idea is to think about interactions in a systematic way for VR, because VR and AR approaches are gaining traction in InfoVis. So this could be a nice paper, definitely, for instance. And I'm not aware that I have read that there actually is one readily available for this. So that could be a good scientific idea even. Yeah. Any further questions now, still related to the content of today, before we move to the organization?
Doesn't look like it about the content of today.
Okay, so now let's move on to the organizational questions, concerns.
Yes. So there was a question from Martin. Perhaps I can just ask him to ask it himself here.
Absolutely.
Martin, are you still with us?
Yes, I am still with you, but I'm doing double meetings with work, so I had to mute somewhere else. Yeah, so basically, I just took a look at the assignment last night to see what the actual requirements were and what would work, like per definition of the assignment. So my first instinct would be like if for the bokeh visualization was just to change the orientation of the bar chart and add some more smaller interaction elements, because that would suffice the assignment. But some of the TAs already stated like that's not really what the assignment is about. But on the other hand, when discussing with students, other students also see that when you change the visualization to, say, a scatter plot, technically the assignment doesn't really change that much. It's still, it's a different visualization, but your axes are still the same. And as long as you don't change the input data, the actual visualization wouldn't change as well. So that's a bit of the
yes. So I'm gonna because I have noticed the question on Discord when I was checking it before the lecture. So that's actually one kind of PSA that I am monitoring even the practical sessions Discord and everything. So I'm not intervening there very much, because I don't have intimate knowledge of the bokeh framework and so forth. But generally, and I'm going to take this down, the assignments are not meant to create busy work, right? So if it's not really clarified what is actually expected, then it should be, I believe. So if you haven't got, I checked the Discord briefly before the lecture.
Yes.
So your belief is that you didn't get a sufficient answer for what is actually expected of you from the TAs.
Well, I think Eanes could just clarify it a bit, but I think that the main point now is that for the bokeh assignment, there should be interaction within the visual itself rather than having interaction outside of the visual or having a change of visual per se. So I think
right.
Yeah.
So maybe like a tooltip or something like that. If you hover over the data points, then I don't know, like I don't know if it's a bar chart and you hover over a bar and it will highlight. So just like demonstrate that maybe. But
yeah, she mentioned dragging the bars directly within the visualization. Right?
Yeah. So to rearrange them. Yes. That's so. Is this a satisfactory answer for you, or shall I discuss this with the TAs?
No, I guess for now that should be enough for me. I'm not sure if there's other students who need more clarification, but I don't think there are anymore.
Okay. Because I mean, again, the general answer is that the point of the assignment is to bring people up to a workable level that everybody can contribute to their projects, right? So it's really not meant to it says it's a pass-fail assignment, so it's a mandatory assignment, right? But it's not meant to really filter people out or kick them out of the course if they miss one small detail or something. It's for TAs to gain knowledge about the programming skills across our population, basically. Right. because it will also help them guide the project. I mean, I have been a TA of information visualization for 3 years, and this information has helped me massively, basically, to kind of. So I think that's the point. So that's the general answer. Specifically related to your question, Marta, if you're satisfied, that's fine. If you believe that you need further clarification, never hesitate to ask for it specifically, and you should get it.
Yeah, sure. Okay, thanks.
Okay. Do we have other questions related to the organization of the course that I can answer maybe for you? Well, if there are none, then I'm going to hang out on Discord after the lecture again, and try to answer everything that we might have missed. Let's please continue the discussion about interaction and evaluation in the Discord channel beyond the lecture if you're interested. Thank you for coming to the lecture, and I'm going to see you next week. Good luck with the rest of the week within this course and beyond. Bye bye.